chapter number 2, inverse trigonometric functions. So we say that inverse function of f exists if f is both 1 1 and onto, and is denoted by f inverse. Okay, so inverse function of f exists if f is both 1 1 and onto and is denoted by f inverse. And in a previous year you have studied that trigonometric functions are not 1 1 and onto over their natural domains and ranges, and hence their inverse do not exist. So in this lesson we shall study about the restriction, that means limitations on domains and ranges of trigonometric functions, which ensures the existence of their inverse, and we also observe the behavior through the graphical representation. So how do you know particular trigonometric function is invertible? Let's find out for a trigonometric sine function, sin x. So to say that sine function is invertible, it should be 1 1 and onto, right? So let us check onto function of sine function. So the range of sine function is -1 to 1, yes or no? So sine function, if you consider a sine function is having a domain, this is already there in your previous year. Okay, so domain as R, set of all real numbers, and range as closed interval -1 to 1. Okay, so what does it says? The sine function, the value of sine function does not go below -1 and does not go above +1. Okay, so the range of sine function is -1 to 1. So let us consider a graph of sine function first. So we know that sine 0 will be 0. Get the graph. Okay, we must know what are sine 0, sine pi by 2, sine pi, sine 3 by 2. Unless we know this, we cannot draw any, or we cannot represent any of the graph. Okay, so just refresh those values, okay, so that it is easy to represent a particular graph. So here sine 0 is 0, sine pi by 2 is +1, and sine pi is again 0, and sine 3 pi by 2 is -1, and sine 2 pi is again 0. So it lies on a 0 lies on a x-axis. So this is, by joining these points you'll get a graph of sine function, something like this. Okay, so here also in the same manner, minus pi by 2 you'll get -1, and sine of minus pi is 0, and sine of minus 3 pi by 2 is +1. So here the graph is something like this. Okay, so this is the graph of sine function. So now to check whether this is onto function, so what we'll do is, here we know that the range of sine function lies from -1 to 1, right? So if we consider any point on this y-axis, from -1 to 1, any point, okay, in between -1 to 1, so there we will get a corresponding value of x. Okay, so if you consider a point over here, so here you'll get a different value, so here also you'll get a different value of x. Therefore you can say that the function is onto function. We shall move on to next condition to check whether it is 1 1. So to check 1 1, let's consider a horizontal line. Okay, let's consider a horizontal line and place it on a graph like this. So let us consider a horizontal line and place this line like this. So you can see that the horizontal line cuts the graph more than 1 point. Okay, you can see that the horizontal line cuts the graph more than 1 point, at more than 1 point. This means that the sine function has the same value for more than one value of the variable x. So this function cannot be 1, 1. So now we have said that the sine function is onto, but it is not 1, 1. Therefore, sine function is not naturally invertible. Therefore, you can say that sine function is not naturally invertible. Let me tell you something shocking. In a similar way, all the other trigonometric functions are also not naturally invertible. So how come we study inverse trigonometric functions when the functions are not invertible? Is there a way to make trigonometric function invertible? We'll get the answer to these questions in a future videos, and also how we can find the inverse function of trigonometric function, and also we'll study different properties of inverse trigonometric functions as similar to the trigonometric function.